In this video, we're going to go over how to calculate limits of infinity for a rational function. So when you have a rational function, which is a polynomial divided by a polynomial, there's a few different rule sets that make calculating these pretty simple. So if you take a look at our first example here, you'll see that our highest degree in the numerator matches our highest degree in the denominator. So when you have this kind of scenario, which is this first rule here, and they're equal to each other, you can just divide the leading coefficients. So in this case, our leading coefficients is 3 and 2. So the answer is just 3 over 2. So the limit of x to infinity is equal to 3 over 2. So here's another quick example of that. You have 3 minus 16x squared, and then that matches the highest degree in the denominator, which is 8x squared. So once again, you would just divide negative 16 over 8, and your final answer is negative 2. So when the degree in the denominator is higher than the degree in the numerator, your answer is just always going to be 0. So this is this third rule here. So this limit going to infinity is 0. In the case that the degree in the numerator is higher than the denominator, you just will divide both these values together. So in this case, it would be 5x over 3 divided by 5x. These 5's cancel out, and this x takes one of these x's away. So you have a limit which is equal to x squared. And then if you plug that infinity in, your final answer, infinity squared, is just going to be infinity. Now if you look at this problem here, this leading coefficient is a radical number, but it's not going across the entire numerator or over the variable here. So you just treat this like you treat these two over here, where the degree of the numerator matches the denominator. So all you have to do is just reduce this radical. So this turns into negative 2 radical 3 over 2. These 2's cancel. You end up with a final answer, just negative radical 3. So pretty easy. Just make sure you try to identify the highest degree in both your numerator and denominator, and just figure out which one of these rules best applies for it. Now we're going to go over a couple examples where there's a radical in the numerator. And pretty much when you have a radical in the numerator, or even in the denominator, you can use the same rule system. Just wheel a limit. Alright, so just looking at this one, you have a radical that spans the entire distance of the numerator. So an important thing to note here is that when you have a situation like this, this finite value right here can essentially just be neglected. So all you have to do now is just factor in this radical in the numerator. So you have the square root of 25, which is equal to 5, and then the square root of x squared. Now if you recall, this is equivalent to saying that x squared is to the 1/2 power. So that'll just give you an x. Now that we have that figured out, you can rewrite it where you have your 5x value in the numerator over 3x plus 5. Now if you look at it without the radical, you notice that these degrees match. So we can use our rule 1 for this. So we would just divide 5 over 3. One thing to note when it comes to having a radical in the numerator, or just having a radical in a problem like this, is that you have to take into account your limit sign. So since our limit sign is positive here, our final answer is going to be positive. If it was to be a negative, then this would be a negative 5 over 3. We'll do one more radical example. So we'll have a 25x squared minus 7 over 15x plus 2. So very similar to the last problem. Once again, you don't have to account for this finite value here. We just need to get the square root of this, which turns into 5x. And then we have that over 15x plus 2. And then since these degrees match, we will go ahead and get a final value of 1 over 3. Since our infinity sign is positive, it remains positive. So pretty easy. I mean, these problems can get a little complicated if you don't really understand these rule sets here. But if you stick to these 3 rules, you'll be able to solve pretty much a majority of your infinity limits that you'll come across.